Rational exponents are exponents that are in the form of a fraction. If we let a be a real number and let n be an integer such that n is greater than 1, we can say that a to the 1 over n is just the nth root of a. We can kind of expand this out a little bit, and we can say that let a be a real number and let m and n be positive integers such that m and n share no common factors, meaning they can't be simplified, and n is greater than 1. So we can say that a to the m divided by n can be rewritten in these forms here, but more specifically can be written as the nth root of a to the m. So what's in green is the more important that you should be aware of, but the other two in the middle are still 100% the same. But if you take the denominator of the exponent, you can bring it to the front and call it the index of the root. So what we're going to do is we're going to convert these to radical notation. So 16 to the 3/4 power. So 16 to the 3/4. We can take our denominator 4 and we can move it to the front and call it the index. So this is the 4th root of 16 cubed. Now from here you can do 16 cubed and then take the 4th root of it, or you can try and take the 4th root of 16 then cube it. I believe doing the root first and then the raised 2 is easier, but whichever you believe is simplest is what you should do. So 4th root of 16, I can say that that is 2, and I keep my cube, so 2 cubed, and that gives me 8. So 16 to the 3/4 power simplifies to 8. Next we have 32 to the 2/5. So again, 32 to the 2/5. And I take the denominator, which is 5, and I'm going to bring it to the front and call it my index. So the 5th root of 32 squared. Again, I'm going to see what the 5th root of 32 is, and that is again a 2 and squared. So 2 squared is going to give me 4. So 32 to the 2/5 power reduces down to just a 4. But we can do this with variables as well. X to the 9/2 power. So again, I look for my denominator. It's a 2. So I'm going to bring it to the front as my index. So it's going to be square root of x to the 9th. And to simplify it, I see how many times 2 goes into 9, which is 4 times, with a remainder of 1, so 1 remains in. So x to the 9/2 power is x to the 4th square root of x. Finally, c to the 5th d to the 1/3 power. So I'm going to rewrite this. I'll write it out here, d to the 1/3. I'm going to take my denominator and move it to the front as my index. So I'm going to get the cube root of c to the 5th d. And since it has an exponent of 1, I don't have to do anything really different. So 3 can go into 5 one time with a remainder of 2. And 3 cannot go into 1 evenly, so the variable d stays inside. And so my simplified solution for c to the 5th d to the 1/3 power is c cube root of c squared d.